how to stop hackers from entering your business. Welcome back. In the last video, we broke down the 5-step penetration testing workflow that security-minded companies use to stop betting their future on luck. If you remember, the steps are discovery and scoping, external testing, internal testing, reporting, and remediation. Today, we're going to focus on a critical, often ignored component of the external testing step: web application penetration testing. Why is this so important? Most companies spend all their time securing the network, the firewalls, the VPNs, but their most critical data and their path to revenue all run through one or two public-facing web applications. A single bug in that app is an express lane for an attacker to steal customer data, halt operations, or take the whole business down. Most web app pen tests are either an automated surface-level scan that misses 90% of the real risks, or a basic test that only checks for the top 5 or 10 common vulnerabilities. In this video, I'm going to break down the specific 3-phase web application penetration testing system that serious companies use to find the business-critical flaws that automation misses, see exactly what an attacker can do once they bypass authentication, and get a prioritized list of fixes based on real business impact, not just a technical severity score. If you're new here, my name is Dan Duran. I'm the CTO of Rhino Cybersecurity, and we help organizations that don't want to gamble their growth on a single cyber attack. Day to day, that means running in-depth security tests on web and mobile applications, finding the specific exploitable flaws that put customer data at risk, and helping development teams turn "we hope it's secure" into "we know the risks and we fix the most critical ones." Let me show you the system. Phase 1. Defining scope and attack scenarios. Just like the overall penetration testing workflow, the first phase is all about getting the scope right. With web apps, this is even more critical because the application logic is where the real risk lies. Most organizations start web app testing with a vague idea like run a test on the login page. Non-systematized version. Vendor runs a quick scan on the public URLs. Internal, authenticated functionality, like the admin dashboard or payment processing, is ignored. They only check the OWASP top 10 list. You get a low-value report that only talks about non-critical issues. Systematized version. You always start with a short scoping workshop to define the business context of the application. Identify critical functionality, user registration and login, authentication and authorization, data access paths, e.g., retrieving customer records, payment processing, e-commerce checkout or billing systems, administrative dashboards or management features. Define attack scenarios. Unauthenticated. Can an outsider without a login bypass the paywall or see customer data? Authenticated user. If one regular user account is compromised, can they access data belonging to a different user or escalate their privileges to admin? API endpoints. How is the API used by the mobile app or front end secured against unauthorized requests? Rules of engagement. Define what constitutes a valid test, e.g., limit automated traffic to certain hours. Agree on data to be used, e.g., only test with fake accounts or specific test data. Output of Phase 1 equals a document listing the application's critical functions and the agreed-upon attack scenarios. Phase 2. Deep manual analysis, beyond the scanner. Now we move to the actual testing. This is where the difference between a real penetration test and an automated scan becomes obvious. What most companies do, run a commercial web app scanner. Get a report with hundreds of high, medium, low findings. Patch the easy-to-fix things, like a non-critical HTTP header setting. Problems. Scanners are great for known technical vulnerabilities, but are blind to business logic flaws. They can't simulate a nuanced attack that requires multiple steps, human intelligence, and understanding the application's purpose. Systematized web app testing, authentication and session management testing. Can we use a stolen session token? Can we guess or manipulate password reset tokens? Is multi-factor authentication easily bypassed? Authorization, access control, testing, vertical privilege escalation. Can a low-privilege user, like a basic account, gain access to admin features or change their own role? Horizontal privilege escalation. Can one user access data belonging to another user, e.g., change the ID number in the URL to view a different customer's invoice? Business logic flaw. Hunting. Can an attacker manipulate pricing in an e-commerce cart to purchase an item for $0? Can a user spam a system by bypassing rate limiting on a form submission? Can a user delete another user's account by manipulating the request? Client-side and input validation. Find and manually exploit common vulnerabilities like cross-site scripting, XSS, SQL injection, SQLI, and command injection, focusing on how they lead to deeper compromise. Deliver concrete application scenarios. We used a parameter manipulation flaw, business logic flaw, to successfully view and download all customer invoices, bypassing all authentication. We escalated a low-privilege account to domain admin by exploiting a misconfigured password change API endpoint. Phase 3. Impact-focused reporting and development feedback. A web app pen test is useless if the report can't drive the necessary changes in the development pipeline. The reporting must be tailored to both the executive team and the development team. Typical reporting: 150-page PDF with scanner output. All findings are rated high if they are technically severe, even if the business impact is low. Developers struggle to reproduce the findings or understand the fix. Systematized reporting, executive summary for leadership, CTO. 1 to 2 page summary focused on application risk. Clear statements like, external attackers cannot steal customer payment data through the application. Top 5 critical flaws tied to specific business impact: revenue loss, data theft, compliance violation. Developer-focused technical findings. Prioritized list of flaws grouped by the relevant code base or feature. For each finding, detailed steps to reproduce. Exact requests and responses used for the exploit. Proof of concept. Clear evidence of the successful compromise, e.g., a screenshot showing unauthorized access. Clear remediation. Code-level advice on how to fix it and prevent the entire class of vulnerability. Verification. Check. A description of how to verify the fix works. Result. Leadership understands the application's exposure and can fund the fix. Engineers have an exact, actionable task list to eliminate the risk without guesswork. Let's summarize the web application penetration testing system. Phase 1. Discovery and scoping. Build a clear scope tied to critical application functions and define the core attacker scenarios. Unauthenticated, authenticated, API. Phase 2. Deep manual analysis. Go beyond the scanner to find deep, exploitable business logic flaws, severe authorization issues, and critical input validation errors. Phase 3. Impact-focused reporting. Provide an executive summary tied to business risk and a technical report that gives developers precise, reproducible steps and code-level fixes. This is how companies that rely on their web applications to drive growth move from hoping their code is secure to knowing exactly what their critical application exposure is. If you want a deeper breakdown of a real, anonymized attack path where a web application flaw led to internal network access, let me know in the comments with "Show me a web app attack chain." And if you're responsible for security in a company that's growing and you don't want a single web app incident to derail that growth, subscribe for the next videos in this series. And if you want this done properly for your organization, reach out to us at Rhino Cybersecurity. Use the Contact Us link in the description to book a conversation with our team, and we'll help you plan and execute a tailored web application penetration test for your environment. Rhino Cybersecurity. Protect with passion.